Well, let's finish up our week as we've been talking about sound just about all week long in science. We'll finish it up with another digital lesson today, thinking about how sound travels through solids, liquids, and what do you think's missing? Should be the word gases there, shouldn't it? How does sound travel through these things? So we've learned already this week that sound travels through solids the fastest, through liquids the next fastest, and through gases the slowest. And we've talked about sound moves in compression waves. So all of these instruments we see here are making sound waves, and then our ears pick up those waves. We've talked about as the wave moves, you can see the crest, the top of the wave, the trough, the bottom of the wave. We talked about how many waves there are per second is frequency. We've talked about how high it is from the midpoint to the top of the crest is amplitude, and volume is how loud or soft the sound is. So we've learned lots of vocabulary this week about sound. So let's take a look at this digital lesson on this Friday, and then we'll be done with science for the week. You won't have an assignment today. You'll just need to listen to this from beginning to end, okay? So here we go.
Welcome to the lesson, How Does Sound Travel Through Solids, Liquids, and Gases? In this lesson, you will investigate how sounds are made and how they are transmitted. Two astronauts are on the moon and are trying to have a conversation. Can they hear each other? Do you think sound waves can travel through empty space, that is, through a vacuum? Keep going to find out. Sound is a form of energy produced when something vibrates. Put the steps in the correct order.
Okay, sound moves through the air. Sound waves are formed. Strike an object. Sound reaches the eardrum. Well, you got to make some sound waves first, so I think that's going to be step one. I guess I'm wrong. Oh, we're playing drums. You got to hit an object first. There we go. When you hit it, it forms sound waves, and then they move through the air, and then they reach our eardrum.
You got it. Vibrations produce sound waves in the air. Sound waves cause your eardrums to vibrate. Signals caused by these vibrations are transmitted to your brain by the nervous system. In this experiment, an alarm clock was put in a glass jar. With a vacuum pump, we can take out most of the air in the jar. Do you think we'll hear the sound of the alarm when there's almost no air in the jar? Look and listen. Sound is a wave that is transmitted through a material, a solid, liquid, or gas. Without such a material, as in a jar with almost no air, the sound wave cannot reach our ears and be heard. So those astronauts on the moon definitely need their radios. Here is what you'll use to investigate whether sound waves travel at the same speed through different materials. Different materials: air, water, rubber, wood. You'll choose the materials you want to experiment with. A sound source and stopwatch. The stopwatch measures the time. You'll click when the wave travels 100 meters. A data table. You'll record your results here. Tools to control the model. You'll calculate the speed of the sound wave. You'll slow the motion of the sound wave to get a more accurate time. You'll click Run to start the sound wave.
Sounds complicated, but we're going to try this.
In this experiment, you'll investigate whether sound waves travel at the same speed through different materials. What do you think? Type your answer in the box and then click OK.
Well, we already know the answer because we've already done the lesson, so we know. Do sound waves travel at the same speed through different materials? No. They travel through solids more quickly.
Continue to see if your prediction is correct. What is your plan for investigating whether sound waves travel at the same speed through different materials? Type your plan in the box and then click OK.
Well, we're going to test how quickly this sound travels through air, through water, through rubber, and through wood using this experiment they have set up for us. And then we're going to find out if we are right or wrong. So here we go. Let's type that in. We'll record the speed of sound as it travels through 4 different materials.
Check your plan. Did you set a goal and include these steps? Choose a material. Measure the time it took the sound wave to reach the 100-meter mark and record it in the data table. Calculate the speed of sound and record it in the data table. Repeat for the other materials. If your plan does not include these steps, you can change it. Once you've finished, click the next button to move on. Are you ready to investigate whether sound waves travel at the same speed in different materials?
Yes.
Do the experiment for each material in the list. Choose the material you want to experiment with. Start with air.
Okay.
Click to generate a sound wave. Click the stopwatch when the wave reaches the end of the material, a distance of 100 meters. Click to reset, and then repeat the experiment.
Okay, so we got 0.34.
Use these slow motion buttons to make it easier to measure time more accurately. Record the time in the data table.
So we're going to make it slower. 0.32. Let's do 100 times slower. 0.33. 1,000 times slower. This one will get us the closest, won't it? But it's right here. May take a little while to do it this slow. I still think it's going to be like 0.33, 0.34 though. Oh. I didn't let it go all the way. I'd say another one, 0.32, wouldn't you? So we're going to say that. Go through air. Time is 0.32 seconds. Okay. We'll figure out our speed here in a minute. Now let's do water.
Calculate the speed of the sound waves by dividing the distance by the time. Record the speed in the data table.
Are you in the middle of a lesson to your kids?
I'm recording. Yeah, it's okay. They'll come on in. I'm paused. I can pause. Okay, I'm back. Miss Spoon came in to see me and asked me a question. Somebody's coming in all the time during our lessons, aren't they? So let's look at this. So we're going to divide the distance, which is 100 meters, by the time to get our speed. So it's going to be 100 divided by 0.32. 100 divided by 0.32 is, okay, the speed is 312.5 meters per second. Okay. So 312.5 meters per second is how fast sound traveled through air. Now we know it's going to travel faster through each of these, so our number should be higher here, shouldn't it? So here we go. Let's choose the water.
Repeat these steps for the other materials.
And we'll keep it at 10 times there. And reset. We've got it moving through water now. I better get ready. It's going to go faster, isn't it? Here we go. Whoa. 0.08 seconds. I couldn't hardly catch that one. Let's try it again at 100 times slower. 0.9. I'm going to do that again. I wasn't ready. Yep, 0.8. Pretty close. Let's do it 1,000 times slower. 0.7. Okay, it wasn't quite there, so we're going to say 0.8. 0.8 seconds. That's quite a bit faster, isn't it? It went 0.32 seconds. It's what times 8 is 32? 4. So it's 4 times as fast through water as it is air. So now let's calculate our speed. So this time we're going to divide. Better clear it out. Divide 100 by 0.8 seconds, and it's something's not right. Did I not do something right a minute ago? Let's go back and work that first one. 100 divided by was 0.32 is, that was right. Okay, something wasn't right. 100, no. Look, Mr. Helton, it's not 0.8, it's 0.08. That's what I did wrong. Sorry, guys. Okay, so 100 divided by 0.08 is, wow, yep, that's about 4 times as fast, isn't it? So the speed of sound through water is 1,250, get my comment in there, meters per second. That's pretty fast. All right, let's see how fast it would travel through rubber, like a rubber tire. Reset it. I have a feeling there's no way I'm going to get this in time. What is going on? I thought it would go faster, didn't you? We're at 10 times slow motion. Does this make sense to you? It didn't make sense to me. Huh. Well, let's try this again. Got it through rubber. Got it 10 times slow. Hit it. And go. I'm a little confused. I thought it would travel more quickly through rubber, didn't you? .76. We'll do it 100 times slower. That's pretty slow already. But here we go. Must be something about rubber that makes it travel slowly. I thought rubber was a solid, though. I thought it would go faster. .78. Okay. We'll trust this experiment. 1.78 seconds. So now let's do our speed. So we're going to clear it out and divide 100 by 1.78. And that's not going to be nearly as fast as the others. That's just 56.2 meters per second. That doesn't make sense to me. But we'll trust this experiment for now. And we're going to go to the wood. Okay. And let's see how fast it travels through the wood. What? Well, that was fast. Okay. Slow down. Here, try it again 100 times slower. Well, I still didn't catch it. 1,000 times slower. Wow. And it's done. 0.03 seconds. Okay, so we knew it was going to travel faster through the solid, didn't we? Okay, so let's do our calculations. Our speed, 100 divided by 0.03 is, wow, 333.3 meters per second. So really fast through the wood. So the only thing that surprised me about this experiment is the rubber. Maybe it's going to tell us why it moves so much more slowly through the rubber than anything else. Do you know why? Do you have any idea why it would? I don't know. Let's see what it says.
Analyze your results. What did you find out about the speed of sound in different materials? Type your answer in the box and then click OK.
Sound travels at different speeds. Okay. Through different materials. Okay.
You may have concluded that sound waves travel at different speeds through different materials. The speed of a sound wave is affected by the medium or kind of material it travels through, either a solid, a liquid, or a gas. In general, it travels faster the denser the material. The speed of sound is also affected by the temperature and internal structure of the material. How does your conclusion compare to how scientists explain this? Type your answer in the box and then click OK.
We agree. They said the same thing we did, just in more words as always.
You concluded that sound travels at different speeds through different materials. Does sound travel at the same speed in all kinds of gases? To find out, repeat the experiment doing the steps you did before, this time using the gas helium. Calculate the speed of sound in helium and compare it with the speed of sound in air. The generally accepted speed of sound in air has been provided for you.
Okay, so let's go back to that rubber tire. So do you remember when they were showing in a video yesterday about recording studios and how sometimes they might pad the walls with different materials that would absorb the sound? I'm thinking that rubber is like one of those materials that would absorb the sound and make it travel more slowly or even stop it from traveling. Even though it's solid, I think it's made up internally, as he said a minute ago, the internal structure. I think the internal structure, what it's made of rubber, is made in such a way that it slows the sound down really, really a lot. And so he never did explain that in this lesson, but I'm pretty sure that's why. So if you want your room to be quiet, maybe you can put some rubber tires on the wall. It'll slow the sound down. Well, let's do this experiment. So air, it's like the air we breathe. And you know what helium is? It's the balloons you fill with helium and they float up in the air. So we're going to see if sound travels faster through air or through helium. You have a prediction? I think helium is probably lighter than air because it can float in the air, which makes me think it has less particles. So I think it'll travel faster through helium, but I don't know. I could be wrong. So here we go. Let's hit play and try it through this helium here. Okay, so about 0.10 seconds. We'll slow it down just a little bit to get it even more accurate. 0.10 seconds. Okay, so it took 0.10 seconds. So let's do our speed. 100 divided by 0.10 is 1,000 meters per second. So I think I was right. It travels just about 3 times as fast through helium than it did through air.
You've learned a lot about sound waves and different materials.
Okay, I'm back. Miss Murph Smith came in. This is a busy day of people coming to my room today. So here we go. We'll resume it.
Sound is a form of energy produced when something vibrates. Sound waves must move through a medium, some kind of matter, either a solid, a liquid, or a gas. The speed of a sound wave is affected by the medium it travels through. Now that you've finished the lesson, click the lab report button to save or print it.
Well, we've learned so much about sound this week, and I thank you for being good listeners. You didn't have a whole lot of science assignments. Next week, we'll get into even more details about sound. And so I hope you have a great weekend. Listen to some nature sounds on this beautiful weekend. Turn on your radio, listen to your favorite music and the sounds that it makes. Do all those fun things this weekend. and think about all the things we've learned about sound. We will see you Monday. We'll learn some more fun science.